Hi, this presentation has been prepared for Berkeley Energy and Resources Collaborative Energy Symposium 2012 E-Symposium. The talk I'm sharing with you is on the energy subsidies track, and I want to discuss a little bit more about the potential misuse of subsidies in renewable energy, specifically a case study in biofuel in Mexico. To put some context into the talk, let me share first with you the primary energy in Mexico. As you can see, a large portion of the primary energy that we have in Mexico comes out of fossil fuels. Specifically, I'm talking about oil that accounts for almost 2/3, combined with natural gas and coal. There's just a small portion of conventional energy sources that we'll be dealing in a moment. Probably one of the main reasons for Mexico to be so dependent on oil is that we used to have a lot. To give you an example, in 2009, Mexico produced 2.6 million barrels a day. But to make things more critical, if I were to show you the figures for a couple of years before, that 2.6 million barrels a day used to be 3.5 million. That was a clear indication that our main resource was depleting. As a response, our government has embarked into a series of renewable energy projects. Just to mention a few of them, we can talk about prospective projects on solar energy, geothermal capacity with existing and prospective projects in the north and in the central Mexico, and a very well-known sun which is adequate for wind energy just over here on the south part of Mexico. In addition to that, we have been benefited by a wide variety of climates, which in turn provides a good landfill for several feedstocks to be used in case we want to also join the biofuels race. So one of the reasons we might be interested in biofuels in Mexico was because there are a lot of incentives and important things to consider here. Number one, this can be in response to the rising price of fuels. Number two, we've shown before that we had an increased dependence on fossil fuels, and therefore energy security might be at risk. And very important, there is in some cases a supposed contribution to slow down on climate change due to the use of biofuels. So one of the best ways for us to evaluate how convenient a new biofuel venture was is by analyzing that within a management of technology framework. With this framework, we try to understand the basic science behind biofuels, the logistics and production reasons for that type of projects to be embarked, and the energy and environmental implications of them. Operations research also serves to understand the sensitivity of each of these projects. We want always to understand whether it makes economical business sense, and at the end of the day, and as it should be with all management of technology frameworks, it should point toward a better society. So let me first share with you this case study that was designed for a northern state in Mexico called Sinaloa. There were some plans to set up a biofuel production plant over there. The idea was to take advantage of the large amount of corn that is produced there and convert part of that into ethanol. The project seemed to have a good business sense, and that could be stated by the ethanol demand forecast and the supply forecast. In other words, there was a need for gasoline, and there was already a feedstock that could help to produce that. In a broader context, we could also see that domestic sales of gasoline were considerably higher than the domestic production of gasoline. Therefore, ethanol was supposed to be one of the main opportunities to fill this gap that we are pointing out here. to help matching demand and supply of domestic gasoline. As part of the process, we also try to look into the environmental implications of this type of projects. For that, we used a commonly applied tool called life cycle assessment, where we were just trying to understand that for a given project with a goal, scope, and definition, there was a need to come up with the inventory of emission, transform that into an environmental impact, in this case, green global warming potential, and understand chances for improvement. In the following slides, we will try to learn more about the life cycle assessment of this system. For the life cycle assessment, we try to understand the main activities related to corn production, transportation of that corn into a facility where it eventually is converted into ethanol, which in turn is transported into final destinations and allowed for ethanol consumption. In the following slides, I will try to share with you partial results on each of these three main stages: corn production, ethanol production, and ethanol consumption. For corn production, we took into account the production of fertilizers. There were three varieties of fertilizers. We're just showing one here for time reason. We're trying to get a good understanding on how much fertilizer will be needed, where that fertilizer will come from, and the environmental effects associated to the production, transport, distribution, and use of those fertilizers. In addition, we're trying to come up with an energy balance. Therefore, all main activities used for instance, sowing and harvesting of corn, we're considering as part of this study. We got values for agricultural machinery, electricity, liquefied petroleum, natural gas, gasoline, and diesel fuel. The second part of this study was related to ethanol production. And even if so far there were not ethanol facilities available in Mexico at the time of the study, we managed to get a good understanding of the process plant. We took into account some design of production facilities which were already operating in the United States. After analyzing data from some processes simulation, public available data on plants that were already operating in the United States, and bibliographical references, we found out something that was not very pleasant. We identified that at least for the production of ethanol, there was already a negative balance. Negative balance that implied that a lot of more energy was needed in order to produce a single unit of energy worth of ethanol. Finally, when we run into the ethanol consumption part, we also directly estimated the energy consumed in the distribution of ethanol from the production plant to all purchasing points named gas stations. For this part, the main variable was given on the actual distribution of gasoline from the production plant. We had an idea of the places and destinations that will be served by this production plant, and that was enough to estimate the distance and the associated greenhouse gas emissions. From this analysis, we managed to estimate the energy requirements through the whole life cycle of corn ethanol. And in this case, we found out that the energy required to produce one single energy of ethanol was substantially larger. In other words, we identified a global negative energy balance. These results didn't change a lot under different optimistic, pessimistic, and common scenarios. In all cases, the values were pointing out to above 1 million units of energy. Therefore, results of negative energy balance were consistent. Going beyond the negative energy balance, we try to understand the economic considerations of this project. In order to carry out this analysis, we try to understand what the upfront investment was needed, the main expenses named corn costs, ethanol production costs, freight costs, the main sources of income, which were ethanol sales, distillery grains. After a series of analyses, playing with different discount rates, different scenarios, and so on, we found a constant result. That result was a negative profit. In other words, the net profit for each year was always negative, and the net present value for the first 10 years of the project was also negative. This raised a big question. If we found out that there was a negative energy balance, that there were some environmental implications of these projects, and that apparently the economic considerations for this project were really negative, then what was the real incentive to engage into this type of ventures? A single answer for that is subsidize. If you take into account that in Mexico we provide subsidies for electricity, for agricultural use of diesel, for agricultural use of water, for electricity, and so on, and then you start piling up these large incentives, it will turn out that probably what seemed to be a negative net present value project will become at one point positive. This is a good example on how incentives, when they are not well designed and applied, can turn some businesses into a problem. For this case study, there were also some social considerations to take into account. The traditional fuel for food debate also took place here, basically because we use corn as the main source for tortilla. There were also some considerations for job creators in this emerging industry, and at the end of the day, we were aware that there are some social advantages of these type of projects. However, when we try to look into the reasons for having this type of investments, we found out that Mexico is also playing a role in this large race for renewable energy. Yes, we understood some of the energy implications, environmental implications, and economic considerations with and without subsidies. On top of that, there is a series of taxes and incentives for renewable energy. The menu of options for Mexico is not as ample as in other countries, as we just basically focus on incentives for other tax credits and incentives for net metering, public investment, and public competitive bidding. Probably the most important one, in addition to the previous schemes that we have mentioned, is Mexico's income tax law. This tax law provides a 100% deduction incentive for taxpayers who carry out investments in renewable energy equipment. Qualifying sources like sun, wind, water, and geothermal energy, as well as the one related to this case study, biomass fuel equipment, are eligible for this type of incentive. These incentives represent the bright side of this story, because even if we have mentioned before, Mexico spends significant sums of energy subsidized for electricity, gasoline, diesel, and liquefied petroleum gas, which by the way altogether accounted for more than 1.5% of gross domestic product between 2005 and 2009. There are also good incentives that are actually driving the use and adoption of renewable energy. A good piece of news for that is that there is a good understanding of bioenergy regulation in the country. We carried out some studies and we have managed to identify how, from top-down approaches, the political constitution has given good line to several laws such as Ecological Equilibrium Protection Law, Sustainable Use of Energy Law, and Bioenergy Promotion and Development Law. All of these laws, in turn, have been aligned to some regulations that make sure that all renewable energy projects comply with minimum standards for environmental, social, and energy compliance. Today, bioenergy initiatives in Mexico have gone beyond incentives, beyond subsidies, and they are part of a national development plan. This national development plan, which also has at the top level an inter-ministry strategy for bioenergy, and at a second level some sector programs, including the Special Program for Sustainable Use of Energy, Agricultural and Livestock Sector Program, and Mexico's Strategic Forestry Plan 2025, among others. All these programs, in turn, have given direction to bioenergy programs, such as Bioenergy Introduction Program and Sustainable Production of Feedstock for Bioenergy programs. So, what initially turned out to be a problem of giving subsidies had turned out as the main reason for the country to also start redesigning their energy strategy, and in particularly the bioenergy strategy. There's still a lot to be done, but we believe that this first good understanding of the situation is allowing the country to move into the right direction. If you have any question or comments about this presentation, please feel free to reach out to me at the Haas School of Business, University of California, Berkeley, or also feel free to reach out to the students who are organizing the Berkeley Energy Resources Collaborative Symposium 2012.